Hello, you're watching TelecomTV. My name's Martyn Warwick. We're here in California, in Santa Clara, in Silicon Valley, at the 7th convocation of the ETSI NFV ISG. A whole load of letters there, but basically it's about network functions, virtualization and standardization, and the move from informative to normative procedures for NFV. And I'm delighted to say that I'm with Martin Taylor, who's the CTO of Metaswitch. Okay, Martin, let's get straight to it. As NFV moves beyond theory and into the proof of concept, which is what we're seeing now from phase 1 to phase 2, and we're seeing this movement from the informative to the normative and getting quite prescriptive about the way things are going to go. Proof of concepts are necessary preparatory to large-scale trialling and then to the commercial adoption of NFV. Can you give us some indication of how important you think these proof of concepts are and what they are for and what they are worth in the long term?
Well, I think the ETSI NFV Group has always been very practical and pragmatic in terms of avoiding creating new standards if existing standards can be brought to bear, making the best use of available technologies and so on. And I think the proof of concept program that they kicked off is all part of that kind of practical approach to the problem. So by encouraging vendors and carriers to get together to create these proof of concepts, one of the key outcomes of that is that first of all you learn what's possible, but you also learn about the gaps, and that helps to inform the work program moving forward. We got involved in a proof of concept activity called Cloud NFV, which actually kicked off long before the ETSI group published their proof of concept framework. The Cloud NFV Group anticipated that proofs of concept would be a really good and important activity for the ETSI Group to get involved in. Cloud NFV was kicked off by an analyst called Tom Knoll, who gathered together a group of, I think initially 6 vendors to create a platform for NFV with a strong focus on management and orchestration. And that group, as an NFV platform, needed a virtualized network function to show off the capabilities of the platform. And they looked at the market, and there wasn't a lot out there. I mean, one of the issues right now, if you're building a proof of concept, is, well, where are the virtualized network functions that would really demonstrate the capabilities of an NFV platform? And they selected Project Clearwater, which is our open source cloud-based IMS. I think for a couple of reasons. I mean, one, being open source meant it was just very easy for them to work with it. Yeah. They just downloaded it and started playing with it without it even really needing to involve us, actually. But the other thing is that because it was designed for the cloud from the ground up with a completely clean sheet of paper, it really exploits the power of virtualization in the cloud in a way that VNFs that have been adapted from traditional telco software environments just don't. So Clearwater, for example, embodies concepts like dynamic elastic scalability, in its very underpinnings, and that means that one of the more interesting things you can do with NFV, dynamic elastic scalability, something that an orchestrator needs to control and drive. You need a VNF that's capable of being driven in that way, yeah. Right? And Clearwater is one of very few, possibly still unique actually in its abilities in that space. So the Cloud NFV platform integrated Clearwater, and we're able to demonstrate, firstly, building a large-scale IMS service, in a matter of minutes, literally. And then applying dynamic elastic scalability, monitoring the load on the system, and once the load gets above a certain threshold, actually spinning up additional virtual machines, spreading the load, and showing how that system could absorb growing load, dynamically on demand. So impressive demonstration of the platform, but enabled by the capabilities of Clearwater as a virtualized network function.
Another perhaps rather more prickly question is this business of openness. It's emphasized all the time that NFV, if it's going to work properly, it's going to be a global globally applicable, it has to be open. But you and I live in the real world, and we've been around the block a time or two, and we have seen throughout the history of telecoms, throughout comms and IT in particular, the fact that the reality is more often than not that a particular manufacturer will come up with a standard, very proprietary standard, that de facto becomes the industry standard. And it's not particularly open. How are we going to avoid that sort of same old loop of lock-in yet again this time around?
Well, I don't think we'll ever avoid it completely, and I'll come back to explain why being an incumbent vendor within a telco gives you a very advantageous position. But I think we are moving into a much more open world than historically we've been in the networking space. And just the fact that we can take a piece of hardware from vendor A and a piece of software from vendor B, and we've got a broad choice of vendors in both the hardware and software space, and just put the two together and deliver a network function based on that. I mean, that is a remarkable change that's happened. Obviously not remarkable in the context of the IT world that's been doing this for years, but in the networking space, this is new stuff and revolutionary stuff, and it's about time probably that it's happened. So I think there's clearly an ability to create openness with a judicious mix of de facto standards, most of which, by the way, are coming out of the open source world. So again, that's another difference. I mean, de facto standards in the past have perhaps been more, coming out of the proprietary space. Yeah. But with projects like OpenStack, for example, and this new open platform for NFV initiative that some of the telcos within NFV ISG have kicked off. These are going to provide, real-world implementations that will inform the whole, the whole process, and will provide really key foundational elements. I mean, there's a lot of emphasis particularly amongst the telcos, for most of the platform that NFV is based on to be open source. Yeah. Now, there'll always be opportunities for upselling proprietary implementations or improvements, but fundamentally they have to be plug compatible with the open source stuff. So this is just orders of magnitude more open than anything that we've been used to before. Now the thing that the lock-in issue that won't change is around the integration of network functions with operation support systems. So the fact that you virtualize a network function does not fundamentally change the requirement to hook up the management interfaces of a network function with the supervising systems that provision and monitor and control that network function. It might get a bit easier if those interfaces are implemented using slightly more friendly technologies like RESTful APIs, for example, or message passing buses, or those kinds of things, as compared with more traditional telco interfaces like TL1 or Corba. But fundamentally, there is going to be, there is a management model that will be exposed by the network function, which is going to be individual and specific to each network function. If you try and standardize that, then you will stifle innovation in the network function space. So that isn't going to happen. It's not in the interest of telcos for it to happen. So if you as a vendor are successful in selling a network function and the telco then invests in integrating that with the OSS, BSS, then that creates a kind of vendor lock-in, in the sense that to bring in another vendor's equivalent network function would require them to reinvest in that effort. But I mean, we think it's a reasonable price to pay for them to get best-of-breed solutions, given that they're able to deploy those best-of-breed solutions over a completely standardized, generic and open infrastructure, which is what NFV will provide.
So basically, Martyn, this is all your fault.
Well, I do share some of the blame, yeah.
Okay, let's move on now then to what is the third. I'm beginning to lose track of time. Anyway, the ultimate question, which is this, Martyn. It's the benefits of NFV are very well rehearsed. We know what they are, but there are barriers both to its adoption and deployment. And also we know what they are, but they're downplayed quite a lot. Let's talk about that. What are they, in your opinion, and how do you think they can be overcome?
Right, so I think there are two kinds of barriers. One is the technical barriers, the gaps that the ETSI NFV Group are busy identifying now that need to be filled.
Yeah.
And then there's the telco organisational barriers, which I'll come to in a minute. The technical barriers are actually very manageable, and I think we generally know what they are. The gap analysis, is I think there's a fairly broad consensus about the things that need to be fixed, but they're relatively modest in the grand scheme of things. A tremendous amount of the infrastructure is already there. The hardware is obviously already there. Cloud software like OpenStack actually does most of the work. And actually, if you pick and choose NFV use cases, you can deploy virtualized network functions in production today, and we're already beginning to start seeing this happen. We've got production virtualized session border controllers in real networks now. To realize all of the benefits of NFV and to be able to cope with the wide spectrum of use cases that are being envisaged. Yeah, there is still some technical work to be done, but it's very manageable, and the industry will just get on with it. I think much more challenging is the question of how telcos organize themselves to different kinds of practices altogether. I mean, their traditional procurement method has been for networks. You write a bunch of requirements, you create an RFP, which is all-encompassing. This is everything I need to deliver a service, and you put it out to the industry, and you award it to a vendor that then delivers into your network everything required to deliver that service. If the service doesn't work, there's only one person responsible, and that's the vendor. In the NFV world, if they're really going to take full advantage, they've got to be prepared to build the platform, to hold someone responsible obviously for that platform, but then when it comes to building services, that means deploying VNFs, virtualized network functions, on top of that platform. Who's responsible then ultimately for that service working? Now, they may decide to offload that responsibility to a system integrator, but even then it's a very different way of procuring the bits and pieces that make up that service than they've used in the past. And of course there are a bunch of new skills that they've got to get their minds around managing cloud and virtual infrastructures. Many of them of course have those skills in the IT side of the house, so they need to bring that across. Now they've very much recognized this, and I mean there have been some good material published by some of the telcos, laying out what they know they need to do. The AT&T white paper on the user-defined network cloud, which is in the public domain, is recommended reading here. It very articulately sets out what AT&T has to do by way of changes in organization to do this. But it's a hugely ambitious set of changes that
and it can't happen overnight.
It can't happen overnight. It'll take time. But this is the biggest change that's happened in the telecom industry, probably since the emergence of digital switching. And that was only a technology change. I mean, this is much more fundamental. I mean, yes, this is a technology change, but it's much more fundamental in terms of the way it imposes a reorganization of the entire supply chain vendor ecosystem. The whole bunch of new players coming in here, IT players and software players like ourselves. I mean, sure, we've been supplying telcos for a number of years, but this changes the dynamics in a very dramatic way. So of course it's going to take time.
Interesting stuff though, and real world problems as well, which is nice to discuss. As usual, Martyn, thanks very much.
Thank you.